Hey everybody. So I just slept for a little while, and now that I've sort of woken up and I've realized that it is always about like I watched a video where it talks about how whatever you do, uh, the rate at which you come back to your course. Like suppose there's a flight which is supposed to go from A to B. It plants a course. It plants like a route for it, but then it never really goes in that route. So the main point is basically course correction that they do while they are flying. So despite the fact that they don't go in the same route that they planned, but they end up reaching their destination is because the course correcting rate is very good and very high. That's what I'm supposed to do in my life, where I'm just supposed to, whenever I sense that the direction is going wrong, I'm supposed to course correct it and bring it back to the right direction. And there should be no also meaning associated to it in terms of like key. Oh, this is gonna do this to me. This is what I'm happy. This is what I'm supposed to do in life and stuff like that. No, nothing of that sort. I just have to blindly do that. So that sort of increases my tendency to come back to the right track as much as I can. So now the moment I've realized this, not realized, as in the moment I got to know about this piece of information, which was like very long back ago. So I just became even more reluctant, even more, how about the word? Even more careless, I suppose. I should have been a better word with R. I don't know why. It would have sounded better. I became more careless with an R because I was like, anyway, I know what the secret is. So I can just now course correct anytime. Like not, if not now, in future at least I'll be able to course correct because I know the fact that it's just about course correcting. So that fucking vicious cycle got formed and that ran for quite some time. And yeah, now I am here in front of you to basically finish my tasks of the day. So these are the tasks of my day. Let me show you. Right. So yeah, first thing I have to do apparently is to find a video where it is where I can get to know about the this thing. Mechanics of Material is a lab that we have. So we have to find videos for that lab experiments and just so that I can have a understanding as to what the fuck goes on in my lab. So yeah, let's just start with that.
रिलेशनशिप स्टेटस के साथ साथ घर भी बदलता है।
बदलने दो भाई, क्या कर रहे हो? होने दे रात का बाकी, होने दे रात का बाकी, ना, होने तेरा चेहरा, Mechanics Material Lab. There you go. This is probably something that would work. Let's just see.
In today's lab, we are going to conduct.
I want to see if it's VTU wala or not, because the point is it should be VTU thing, right? Let's see. What uh Belgavi, yeah, there you go, it's a VTU thing. Right, so let's just start.
Test on. Sensor test on.
Maybe should I like look for more options? Wait, let me see if I can find more options. No, not this guy. I want something from me, VTU, because it'll be easier for me to understand. Oh wow, there's a Muslim lady teaching Max. I'm just kidding. Just kidding, just kidding. There's fucking only one YouTube channel. होने दे रात कहानी, होने दे रात, ना 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 ना, होने तेरे नाल चुरा. This one's also interesting, but I don't know. I think that I should just stick to this one because I suppose he's gonna basically teach us a lot of stuff. Okay, let me just bring my lab whatever. Fuck, I need to stand up for that. I need to reveal my body. It's okay. It's such a nice time to actually lose your keys for the Oh yeah, you haven't. I haven't lost it. There you go. I hope I don't expose much. Fuck. Fuck. This is manufacturing processes. I need a mechanics of material lab, guys. Okay, I'll be back. Just give me some time. It's in my bag. I'm back, guys. Almost back. Yeah, there you go. I need something, some rough book kind of shit to have. Maybe this would work. I don't know. Okay, let's go. So basically, we have to. I need a pen. There's a black pen, but I don't know. Let me just wear my specs so that I look cool. Right. So yeah, let's just start with the what is it trying to do? Mild steel using universal testing. Tensile testing is doing, right? Fair enough. Tensile properties. Determination of tensile testing. Wait, what? Tensile testing on mild steel. Using universal testing machine. I don't know what the fuck it is. Determination of wear and tear loss. ठीक है. Shear strength, bending properties, torsional properties to make sense. I don't know about this experiment, bro. Let's at least do bending test because that's something
Good afternoon,
I actually
friends.
have. Bending test on wood? What the fuck? Is that what they do? Bending test? Yeah, there you go. 26 page number. I don't know, man. Like, I mean, it's not mentioned as to what do they do use in terms of specimen. Okay, metallic and non-metallic materials, right? So it's okay. What they can use whatever they want. So aim to perform bending test on the metallic and non-metallic. I am actually reading from this thing from my lab manual so that I can at least gain a bit of like understanding as to what the fuck is going on, and then I'll probably watch the video. Actually, good. That's a good line of working. That's a good line of working. That doesn't exist, but yeah, whatever. So, okay, ठीक है. Universal testing machine they use to test to do the perform the bending machine, right? होने दे रात खराब होने दे रात शराब दिल तेरे अखियों ते कुछ ना मैनू ते तेरे नाल नखरा. Oh my god, I can't get over that song. UTM, UT Universal Testing Machine, hydraulic plus what? Hydraulic type 40 tons, consists of motor-driven pump for producing pressure against the piston, which will in turn transmit the specimen placed between the bending shackles. Three-point bending shackles attachment, a load indicating device to indicate the load against the material, extensometer to find the length, to find the change in the length. Before conducting the experiment, clean the work surface and work table. Make sure both the left and right hydraulic knobs are completely closed. Fix the loading attachment to the lower crosshead and fix the loading attachment. Okay, I just not able to understand. Just let me just watch it.
Today I am going to explain how to conduct the bending test on timber specimen. The aim of this experiment is to observe the behavior of the given timber beam specimen subjected to 2-point loading up to the failure and to determine the moment of inertia, that is I, bending moment M, bending stress F, and Young's modulus, that is E. In order to conduct this bending test on the timber specimen, there are few apparatus which are required. The first one is the universal testing machine. Usually, the bending test is conducted on universal testing machine. And second apparatus which is required for this sample, this test is bending test assembly. And third important apparatus is the vernier caliper as well as the scale and the dial gauge, which is used to measure the deflection during the bending test. And the observations made in this timber bending test are the type of timber. This is the type of the timber, that is the acacia, and the total length of a sample is 554 mm that you have to measure with the help of this scale rule. That is the second important observation, that is called as the total length of a beam or total length of a sample, that is represented by L, that is 554 mm here. And third observation, the bearing length of a sample. So in order to find out the bearing length of a sample, so what you have to do, from this end leave 25 mm and from this end you leave 25 mm and you mark it and draw the line. And the distance between these two lines is called as the effective length of beam, that is represented by the capital L. The distance between these two lines is called as the effective length, that is 504 mm.
Hell nah, bro. Hell nah. I don't like it. ये कौन सा बेडिंग टेस्ट है भाई? ये नहीं होना चाहिए. But it was mild steel beam. This is probably something that's better.
Spotlight shine bright all on me. Got the internet turn like who is she?
Good morning. We are conducting experiment on bending test for the material mild steel beam. Generally, we know that bending stresses the property of a material which is generally applied to resist the load under deformation. So it experiences the maximum strength or maximum stress within the material at its moment of rupture. So in most of the structures, we generally know that the maximum strength of the material upon applying the bending forces need to be resisted by the specimen which we consider. So that type of structures we call it as beams. So we have various types of beams in various applications. So generally for the beams we have different materials to be considered. So in order to consider the mild steel as the beam material, upon applying the bending strength, the material tends to bend. Upon bending the material, it experiences the tensile strength as well as the compressive strength. At the concave phase of the beam, the compressive strength of the property can be seen. At at the convex face of the beam, the tensile strength of the property can be seen. So whenever there exists the tensile strength, there will be the maximum property that can be visualized, where the tensile strength can be able to resist the forces which has been applying on the material. So that maximum strength or the tensile strength, whichever the material can able to withstand before getting into the deformation, that type of strength is considered as the flexural strength. So generally the tensile strength as well as the flexural strength are one and the same whenever the materials are under homogeneous condition. So here we can see the general flexural formula for any type of material is m by I equal to sigma by y equal to E by R. So this is the flexural formula we generally use to determine the bending moment as well as the bending stress. So upon determining the bending strength as well as the bending moment, we can also determine the curvature of any type of beam we consider in the type of the material. So as we know the flexural formula, which generally gives you the clear picture about the bending moment as well as the bending stress. By knowing the bending stress, we can able to determine the deflection of beams. So in order to know the deflection of beams, we have the general equation, that is m equal to Ei into d square y by dx square. So in this equation, the product of E and I, that is Young's modulus of the material into the moment of inertia, is called as the flexural rigidity. So by knowing the general equation of deflection of the beam, we can able to determine the deflection where exactly happens upon applying the bending moment. So so using this equation of the beam, we must measure the length of the beam. Using the scale, we measure the length of the beam. The next, where exactly the load to be applied. At the center point of the beam, we apply the load. Therefore, we must measure the distance between the load and the end of the beam. And we measure the width of the beam. And we consider the thickness of the beam. So before conducting the experiment, we require the specification of the material. Since we have considered the mild steel as the specimen here, we need to measure a certain specification of the given material. So we have the span of beam, that is length of the that. By knowing the to determine the Young's modulus of the material, we require the dial gauge, because as how we apply the load, it needs to deflect. So in order to determine the deflection of the beam, here we are considering the dial gauge. So least count of the dial gauge is known as 0.0.
Should I read this? I think I want to read this. Like, it's a little diversion from the certain stuff that I did. Not little, like but let's just try to read, because it's a little hard also. I'm getting bored of studying that. This is a present extension of observer theory within the context of observer theory. Okay, of within the context of relayed using a mathematically rigorous formulation with category theory as the infinite framework. This will demonstrate how interaction between observers and the relayed can give us hierarchical domains of reality through sampling constraints, information integration, and entropy reduction. Who is relayed? Concept of relayed. Oh, Wolfram, right? Everybody relate to Wolfram here. People Wolfram.
I have not heard this word Rouliad before, so I'm guessing that many of my
I learned that ChatGPT works best with detailed prompts, but I hate typing them. So instead, I dictate.
Many of my listeners haven't either. So before we continue, just what is a Rouliad?
Right. So there's not a Rouliad. There's only one Rouliad.
Okay.
It's so it's a term I invented it. What is it? A couple of years ago now. It's okay. Let's see. We probably have to descend to really understand it. We have to descend a couple of levels in a rabbit hole.
Okay.
But let me say what the sort of nominal definition is. The nominal definition is it is the entangled limit of all possible computations. What do I mean by that? So
entangled limit of all possible computations. What is entangled limit?
Let's say you have a Turing machine, simple idealized model of computation. You have this Turing machine. You start it in all possible states. you look at the Turing machine just does what it does. It has rules, it just keeps running, does what it does. So you start in all possible states. And what you can then do is you say, for this Turing machine, let's say there are two different states of the Turing machine at the beginning. Maybe they merge sometime later. That's, so that can happen. And you're kind of mapping out what are the processes that go on that go from state to state. Okay, so now you don't just think about one Turing machine, you think about all possible Turing machine rules. And in that situation, you start off from one state, and you can apply one Turing machine rule and it goes over here. You apply another Turing machine rule, it goes over here. Now, maybe subsequently, the states, those two different states, will apply some Turing machine rule, they'll merge. So you get this whole structure of branching, merging states of, let's say, Turing machines. Then you continue that for all time. You just keep it running forever. And it then turns out it doesn't matter that you're talking about Turing machines. It's just a change of coordinate system. It's like rotating coordinates, and you're still talking about the same piece of space, so to speak, but you're describing it with different X and Y and Z values and so on. So you could change from Turing machines to cellular automata to all kinds of different models of computation. This limit will always be the same thing. So this limit is sort of interesting because it encapsulates all that is computationally possible, and it is unique. There's, you can describe it in different ways, but there's just one Roolead. Mm-hmm. The only way that it isn't unique is to say, well, it only uses Turing machines. So a Turing machine has certain limitations. Like, for example, if I say, and it's related to computational irreducibility, if I say, here's this Turing machine, is it ever going to reach some halt state? You say, well, I ran it for 1 million steps, it didn't reach a halt state, it's not going to halt, but it is not in general possible to prove with a finite proof that the system will eventually halt or not. And this is a feature of computational irreducibility. Computational irreducibility, I mean, just to give the logical flow of this, the most fundamental principle here is the principle of computational equivalence. The idea that systems are equivalent in their computational sophistication. So then the question is, if you have a system and it's running according to certain rules, and you are saying, I'm going to jump ahead, I'm going to predict what the system does without having to follow all those steps. Well, how are you going to do that? Well, eventually, you have to be somehow computationally smarter than the system itself. You have to be able to say, well, it spent 1 billion steps, but I've got this really clever computational technique that lets me answer that in 3 steps. Okay, but the principle of computational equivalence tells you can't do that. It tells you as a brain, as a mathematician, as whatever else, you are simply computationally equivalent to the system that you're studying. And so that's why you get this phenomenon of computational irreducibility. So that's kind of that's that piece of it. Now,
computational irreducibility can't be. Irreducibility. Into that, no? Reducibility. Yeah. Go from computational irreducibility. It is all from. Is a concept introduced by Stephen Wolfram in his book A New Kind of Science. Suggests that many systems, especially those that are complex, is no shortcut to predict. They mostly almost simulate or conclude the entire process to understand the outcome. Guys, this principle implies that even simple truths could be computationally irreducible.
When you're looking at, but one thing you could say is, okay, well, computational irreducibility is something where you can't jump ahead because you're just computationally equivalent to the system. But I could just say, I just imagine that I have what usually gets called an oracle. Imagine I just have this box that answers questions which take an infinite time for a Turing machine to answer. And you just say, I'm going to attach this box to my computer. Well, with that box, you can go beyond mere computation. You can go to hypercomputation. So there are an infinite hierarchy of hyper-Rooleads which involve more than just ordinary computation. But the one sort of contingent fact, I think, about the universe is we live in the Roolead and not in the hyper-Roolead. And there is a necessary event horizon, kind of a causal disconnection between the Roolead. There's the same kind of causal disconnection between the Roolead and the hyper-Roolead as there is between what we see in the physical universe and the interior of a black hole. It has the same kind of causal, you can't have an effect going from one to the other type thing. So it is not self-evident. It's not something we can prove in some sense that we can find empirical evidence that we're in the Roolead and not in the hyper-Roolead, but it's the same, it has the same kind of status in kind of thinking about what's necessary and what's not, as to say, you know, we are at this place in the physical universe. There's not a thing where you can say, I'm going to prove a theorem that the Earth is at this place in the universe. That doesn't really make any sense. It's just we happen to be at this place in the universe, and given that, we have certain impressions about how the universe works. Well, we happen to be in the Roolead and not in something else, but there is only one unique Roolead. And so then you ask the question, well, so for example, there are many, many questions you can ask. So the important thing is we are sampling the Roolead at one place in the Roolead, which means that, among other things, we have, given the way our minds work, given the way our senses work and so on, we have a particular view of how the universe is working.
Rocks. I'm writing a paper on them. This is a lasting sign between me.
If we were to move ourselves to a different place in Rooleal space, sort of a different place in the Roolead, we would have a different point of view about how the universe works. It's still the same underlying Roolead, but we're sampling it in a different way. Just like in physical space, we can move from here to there and we'll have a different point of view about what's happening in the universe. So in this case, what we're, the way I see it actually, and this is sort of a philosophical prong that is not 100% worked out, but the way I think of it is, you know,
each of two or more projecting pointed parts end of the curve. Oh, it's called prong. There's an image to that. Those are called prongs. Damn, good to know.
So different minds are at different points in the Roolead. They're different points in Rooleal space. So, you know, you can be physically in a different place and you have a different point of view about things. You can be in a different place in Rooleal space, which means you have a different view of, you attribute different rules to the way the universe works.
What the fuck is going on, bro? The cat is less believe in life from another cat. I forgot to mention the word polar motions of the universe. Talking about branching all directions involved with that. Yes, you can view LLM output through mathematical lens. The response is generated by probabilistic models in computation and encoding patterns in dynamic. The problem can be solved by only substituting the thinker's own body instead of Turing machine, and the digits 0 as some kind. Like, I don't know what fucking Turing machine is. Give me some easy video on the comments. Easy keyword, guiding machines. Machine interaction. There's an entire lecture for that. Lecture series for that. Pretty sure I'm not gonna have to. Okay, fucking let's just watch it. Come on.
Back at the start of the 20th century, mathematicians were fascinated by the question, just how much maths can we do? Not by using our gut feelings or intuitions, but just by following rules very, very carefully, by following an algorithm. In order to make that notion precise, we would have to set out just what do we mean by a program or algorithm. And this is where Alan Turing came in with his notion of a Turing machine. Turing was working on a problem in formal logic, and as part of his proof, he had to come up with a notion of any possible algorithm or any possible machine. He had to come up with a very general way of capturing how algorithms or programs or machines would work.
Hello, hello, hello. Hello, hello. So, are we live? ठीक है, हम देखा था, ठीक है, जिसमें लोगों ने प्लस और जो सबट्रैक्शन था उसके जो पीछे का
This is for like general. I think I should pick another book because this book is like general, like endeavors. The bigger book is. Oh, now you're having.
पूरा मैकेनिज्म था वो समझा था, ठीक है। अब इंडियंस जो है ना वो एक दूसरी चीज पे वर्क करने शुरू करते हैं, दैट इज मेकिंग कॉपीज। ठीक है, ठीक है, ये ध्यान से सुनना, ये बहुत ही इंपॉर्टेंट सेगमेंट है और इसको मैं बहुत ज्यादा आगे आगे तक यूज करूंगा। परम्यूटेशंस एंड कॉम्बिनेशंस, नंबर थ्योरी, हर चीज में यूज होगा ये वाला सेगमेंट, ठीक है। तो अगर आपको लग रहा हो कि फिर से कुछ स्टोरी वोरी होने वाली, तो जो भी तुम्हारा भैया थिंकिंग है वो सब छोड़ो, इस पे फोकस करना, ठीक है। ये बहुत अलग तरीके से होने वाला है, ठीक है। सो लेट मी शो यू वाया, मैं इसको स्लाइड्स की तरह शो कर देता हूँ। बाकी मैं कोशिश करूंगा कि मैं ज्यादा से ज्यादा खुद से लिखूं और स्लाइड्स यूज ना करूं, ठीक है। बस जितनी बनी हुई है उतना का यूज करके उसको कर देते हैं, ठीक है जी, ठीक है। तो इंडियंस ने क्या चीज रियलाइज करी कि जब मैं बोलता हूं कॉपीज बनाओ, ठीक है, कि किसी चीज का कॉपी करो, ठीक है, तो जैसे मानो मुझे पांच चीजों की मुझे 7 कॉपीज बनानी है, ठीक है। तो उसके लिए उन्होंने एक नोटेशन बना दी, जैसे प्लस है वो घुमा के बना देते हैं मल्टीप्लाई, ठीक है। नोटेशन किसी और ने बनाई थी बट ठीक है, हमारी स्टोरी लिखी, ठीक है। तो अब आप एक बड़ी सटल सी बात समझिए यहाँ पे, ठीक है, बहुत सटल सी बात समझिएगा। क्या कि जब मैं तुम्हारे सामने लिखता हूं 7 into 5, तो ये जो 7 होता है ना सामने वाला और ये जो 5 होता है, दे आर नॉट द सेम थिंग्स, ठीक है। 7 into 5 और 5 into 7 आर नॉट सेम, ठीक है। इसको आप समझो ध्यान से, ठीक है। फिर आपको समझ में आएगा कि जब मैट्रिक्स में, जब मैं आपको बोलूंगा कि ए मैट्रिक्स, बी मैट्रिक्स और बी मैट्रिक्स ए मैट्रिक्स सिमेट्रिक नहीं होते हैं, तो समझ में तो सबको आ जाता है, बट ना तुम उसके साथ वो नहीं हो पाते हो, फ्लूइड नहीं हो पाते हो, ठीक है। खैर उसको छोड़ते हैं। पॉइंट इज कि जब मैं बोल रहा हूं कि 7 of 5 एंड जब मैं बोल रहा हूं 5 of 7, तो उसमें डिफरेंस क्या है? उसमें डिफरेंस यही है कि 7 एप्पल्स इन 5 बास्केट्स एंड 5 एप्पल्स इन 7 बास्केट्स, ठीक है। इसको जरा एक बार इमेजिन करो, तुम्हें बराबर नहीं लगेगा वो। रियल लाइफ में इमेजिन करने की कोशिश करो कि 7 कुछ ऐसे बास्केट्स रखी हुई हैं और उस सब में 5-5 एप्पल्स हैं और मेरे पास 5 बास्केट्स हैं, उन सब में 7-7 वो हैं। क्या तुम्हें सच में लग रहा है कि यार ये तो बड़ा ऑब्वियस है कि ये बराबर ही होंगे? सोचो, अगर तुम्हारे सामने कोई फिजिकली रख देगा ना ये, तुम बिल्कुल भी नहीं कह पाओगे बराबर है, बराबर नहीं है वो, ठीक है। इट इज बाय चांस कि वो बराबर आ जाते हैं, समझ रहे हो। लेकिन हमारी ऐसी वो हो जाती है ना, कह रहे ये तो बराबर ही है, इसमें क्या है, ये तो बराबर ही है, ठीक है। तो काफी टाइम तक तो ये लगता था कि ये बराबर नहीं है, ठीक है। और काफी सीमिंगली डिफरेंट सिचुएशंस है 7 उसमें एंड उसमें। हुआ क्या कि एक दिन हुआ होगा कि किसी ने अरेंज किए होंगे, ठीक है। तो एप्पल्स सजा दिए किसी ने, ठीक है, यहां पे बास्केट रख दी, समझ रहे हो, ठीक है। यहाँ पे किसी ने बास्केट रख दी होंगी ऐसे करके, ठीक है, ऐसे करके कितनी बास्केट रख दी, समझ गए ना यार, ठीक है। उस पर मत जाना, ठीक है, पर आप समझ गए, ठीक है। ये एक बास्केट में कितने एप्पल्स आ गए, ये 5 आ गए, इसमें भी 5, इसमें भी 5, इसमें भी 5। फिर किसी मैथमेटिशियन ने सोचा होगा या जिस भी इंसान ने सोचा होगा कि यार मैं इसको ऐसे रखूं, मैं इन सबको एक में डालूं, यहां पे डालूं, ठीक है, एक मिनट जाओ, या मैं इन सबको इस वाली बास्केट में डालूं, इन सब इस वाली में डालूं, ठीक है। मैं उल्टा भी तो कर सकता था, मैं ऐसा भी तो कर सकता था कि मैं यहां पे बास्केट बनाता, ठीक है, मैं इधर को बास्केट बनाता, समझ रहे हो बात को, समझ रहे हो, ठीक है। और मैं इस बास्केट में सारी डाल देता, बोलो, राइट। तो वहां से एकदम ऐसे दिख जाता है, एकदम से ऐसे दिख जाता है कि हाँ ये तो ऑब्वियस सी बात थी, ये मेरे दिमाग में कैसे नहीं आई, ठीक है, कि 7 बास्केट्स के अंदर 5 डालो या 5 बास्केट्स के अंदर 7 डालो, बात बराबर होगी। लेकिन फिजिकली इट इज नॉट अ सेम सिचुएशन। ठीक है, अब मैं इसको एक लेवल और आगे बढ़ा रहा हूं। ठीक है, तो यहां से हमारे को एक बात समझ में आ गई कि अगर कोई दो नंबर्स दे रखे हैं, कोई भी दो नंबर्स दे रखे हैं और उनको मैं मल्टीप्लाई कर रहा हूं, ठीक है, तो जब मैं किसी को भी आगे पीछे कर दूं उससे कोई मतलब नहीं है। ठीक है, मैं 5 इंटू 4 करूं या 4 इंटू 5 करूं उससे कोई मतलब नहीं है। ठीक है, अभी इसको हम और आगे बढ़ा रहे हैं, फिर इसको मैं जहां लेकर जाऊंगा वो थोड़ा सा टफ हो सकता है। ठीक है, वो थोड़ा सा टफ हो सकता है, पर ध्यान से समझना उसको। ठीक है, ऑलराइट, अभी थोड़ा बेसिक है पर समझना ध्यान से। ऑलराइट, अच्छा अगर मैं तुम्हारे सामने ये बोल दूं कि यार देखो ये जो 7 बास्केट्स है ना जिसमें 5-5 एप्पल रखे हुए हैं, ये एक डिब्बे में है, और ऐसे मेरे पास 10 डिब्बे हैं, और ऐसे मेरे पास 10 डिब्बे हैं। ठीक है, तो व्हाट यू आर सेइंग इज कि 7 इंटू 5 तो है, 7 इंटू 5 तो है, बट ऐसे मेरे पास 10 डिब्बे हैं, राइट? तो टोटल एप्पल्स कितने हो गए? टोटल एप्पल्स कितने हो गए? ठीक है, तो ये सब भी आपने शायद बचपन में पढ़ा होगा। ठीक है, लेकिन समझो इस बात को कि ये इतनी ऑब्वियस बात फिर से नहीं है। आप फिजिकली अगर इमेजिन करोगे आपको लगेगा कि 1 मिनट ये हम कर क्या रहे हैं, अरे 350 मत बोलो यार कैसी बातें कर रहे हो? ठीक है, क्या ये बात समझ में आ रही है कि इट इज नॉट ऑब्वियस, इट इज नॉट ऑब्वियस। ठीक है, लेकिन हाँ सर इतना श्योर है कि इतना तो पता है कि 7 इंटू 5 बोलो या 5 इंटू 7 करूं वो तो सेम ही आएगा, वो तो सेम ही आएगा। ठीक है, तो अब देखो हम हर तरीके से इसको घुमा सकते हैं। ठीक है, इसको हम हर तरीके से घुमा सकते हैं। ठीक है, कि मानो मैं इसको सोचूं, मतलब देखो यहां तक तो तुम्हारे लिए ऑब्वियस है कि सर 7 इंटू 5 इंटू 10 करो या 5 इंटू 7 इंटू 10 करो, वो तो सेम ही है। ठीक है, लेकिन अगर मैं तुम्हारे सामने एकदम से ये लिख दूं, अगर मैं तुम्हारे सामने एकदम से ये लिख दूं तो इसमें भी कोई प्रॉब्लम नहीं होनी चाहिए। नॉट बिकॉज कि तुमने रटा हुआ है, नॉट बिकॉज कि तुमने रटा हुआ है, तुम अंदर तक सोचो उस चीज को।
7 एप्पल 5 डब्बे, और 7 एप्पल 5 डब्बे, 5 डब्बे है टोटल। उसको मैंने लगा दिया उसमें ये बड़े से ऑर्डर कंटेनर में और छोटी साइड से, राइट? नाउ इसे और 10 बेस कर लेते हैं। सपोज 7 इंटू 5 तो मैंने बना दिया कि 7 एप्पल होंगे और वो सिर्फ 5-5 के जोड़े में होंगे। 5-5 7-7 के जोड़े में 5-5 एप्पल, 5 वो बर्गर जो एप्पल रहेंगे 7-7 की जोड़ी में रहेंगे और 5 बार ऐसे रहेंगे, 35, राइट? और उसको मैंने 10 से मल्टीप्लाई कर दिया। क्यों? क्योंकि मेरे को जो 5 जोड़े बनेंगे उसको मैंने और उसमें डाल दिया। तो नाउ द ऑपोजिट बेसिकली 7 इंटू 5 इंटू 10, let me find sim, but how is the question, right? So 7 into 5 into 10, उसमें क्या है कि 7 into 5 and you've got 7 apples lined up for 7 apples lined up in 5 different boxes, and those 5 different boxes are now those 5 different boxes are kept in 10 different boxes, 10 different whatever. I don't know, but that's what he said, right? How I realize is like there are 10 more of that sort, right? ठीक है, ಸ್ವಲ್ಪ makes sense. Can't get rid of that thought. So come on, be a little more. How do I say? Fucking yeah. Just can't get rid of these thoughts. Similarly, the opposite basically, 5 apples kept in the pack of 5 in 7 different boxes. And 7 different boxes are kept each in 10 different boxes, right? That's the point. Like you calculate this value to find one value. You know what I mean? And that one value will get multiplied with this thing, right? Similarly, this thing we have let's say five. Okay, let's also do this thing. Right, so this is another one, yeah. So here in this particular one, So here we have 5 into 7 into 5 into 10. 7 into 5 into 10, right? So it means 5 into 10 को पहले resolve करेंगे. So 5 into 10 basically means you've got 5 boxes lined up in 10 different situations. जितने भी कुछ बनेगा उसमें उतने apples आ जाएंगे. Similarly यहाँ पे you've got 7 apples kept in 5 different. Okay, this doesn't work like that. 7 apples. So let's assume right. So in this situation we're keeping it as 7 into 5. Oh no, 5 into 7. There are 7 apples in 5 boxes. And that's 7 into 5. Right, so this is 7 into 5. Right, now if I were to do 5 into 10 into 7, what does this mean? It means there are 7 apples that will be kept in 10 के pair में, and then this doesn't make sense, right? Seven apples 10 times डालेंगे. 7 7 7 7 7 8 9 10.
तुम अंदर तक सोचो उस चीज को कि अच्छा ठीक है, अगर डिब्बे में बास्केट्स हैं तो पहले मैं ये गिन लेता हूँ कि टोटल बास्केट्स कितनी हैं. तो अगर 10 डिब्बे हैं और हर डिब्बे में 7 बास्केट्स हैं, ठीक है, तो मैं ऐसे भी तो गिन सकता हूँ ना कि पहले मैंने क्या करा, पहले मैंने सारे बास्केट्स गिन ली, 70 बास्केट्स हो गई. अब उन बास्केट्स में एक एक में 5 एप्पल्स हैं, तो मैं जैसे चाहूं वैसे घुमा सकता हूं. या फिर मैं क्या करूं, मैं बोलूं, ठीक है, आप समझ रहे हो, या फिर मैं क्या बोलूं, मैं बोलूं कि यार देखो, अब ये थोड़ा सा कॉम्प्लिकेटेड हो जाएगा आपके लिए, ठीक है. अगर मैं बोलूं कि यार देखो, जब मैं तुम्हारे सामने ये लिख रहा हूं, पता है, दिस इज नॉट एट ऑल ऑब्वियस. जब मैं तुम्हारे सामने लिखूं ना कि 7 into 5 into 10, ये पता क्या लिखा हुआ है, ये पता क्या लिखा हुआ है कि 10 डिब्बे हैं, उन एक एक डिब्बे से बस 5 एप्पल्स लो. समझ में आ रहा है? ये थोड़ा सा अजीब है, आप लोग मान लेते हो इस चीज को. प्रतीक सोचो, अपने आप दिमाग लगाओ, ठीक है, थोड़ा सा एब्स्ट्रैक्टली सोचो, थोड़ा सा सोचो अपने दिमाग में.
मैथमेटिकली पेपर पे तो आ जा रहा है, बट ऐसे ऑन माइंड नहीं आ रहा है. जैसे सपोज 10 डिब्बे हैं और 7 एप्पल की वो है जोड़ी, तो मैं क्या किया, 7 को 10 से मल्टीप्लाई कर दिया, तो 7 एप्पल 10 डिब्बे में जुड़ गए. अब वो 5 का क्या होगा?
ठीक है, मैं बनाने बैठूंगा तो दिमाग खराब हो जाएगा, इतना बनाना पड़ जाएगा यहाँ पे, ठीक है. लेकिन जब मैं बोलूंगा कि 10 हैं पर उसमें से तुम सिर्फ एक बास्केट की एप्पल्स ले लो, ठीक है, 5 एप्पल्स ले लिए, फिर तुम बोलो कि देखो 50 एप्पल्स होंगे पर यूनिट. अब तुम बोलो कि देखो लेकिन एक एक उसमें तो 7 वो हैं, तो इनटू 7 कर दिया. दिस इज नॉट इजी, ठीक है. सो ये जो आप बच्चे वाली चीजें पढ़ लेते हो ना, बचपन में पढ़ा दी जाती है एसोसिएटिविटी प्रॉपर्टी, ठीक है, दिस इज नॉट एट ऑल ऑब्वियस, ठीक है. श्योर है, वही तो पॉइंट है कि समझ नहीं आएगा, ठीक है. पर अभी मैं चलो एक चीज दिखाता हूं, उससे समझ में आ जाएगा, ठीक है. जैसे ये है, ठीक है, जैसे ये क्यूब है, ये क्यूब है, ये क्यूब है, ठीक है. अब मैं देखो इसमें बहुत आसान काम से आपको समझ में आ जाएगा, ठीक है, क्या कि ये 1 2 3 4 5 6.
So one thing that I've understood now is that associative property doesn't make sense all the time.
ठीक है, तो ये 6 है, ठीक है, और ये क्या है, ये आपका 3 है, ठीक है। तो अगर आप सोचो, अगर आप एक फेस को ले लो, ठीक है, आप एक प्लेट को ले लो तरीके से, तो इसमें कितने टोटल बॉल्स हैं? तो बोलोगे 6 × 3 है सर, और कितने हैं? ठीक है, और सर इसी को आप 3 × 6 भी कर सकते हो, आप 3 × 6 भी कर सकते हो, है ना। अब आप सोचो कि जो एक प्लेट है, इसी को मैंने 4 बार अराउंड वो कर रखा है, तो मैं इसी को बोल सकता हूँ × 4, इसी को बोल सकता हूँ × 4, राइट। ऐसे करके मैं सारी की सारी बॉल्स नाप सकता हूँ जो इस पूरे ओवरऑल डिब्बे में होंगी, राइट। लेकिन मैं चाहूं तो इसी चीज को एक दूसरे नजरिए से भी देख सकता था, ठीक है। आपको समझ में आ गया? एक तरीका ये हो गया, दूसरा तरीका ये हो गया, ठीक है। पर मैं इसी चीज को एक और तरीके से भी सोच सकता था, ठीक है।
Yeah, we visualize it in terms of like a cuboid.
वो क्या था, मैं ऐसे भी सोच सकता था कि व्हाई नॉट आई स्टार्ट फ्रॉम हियर, ठीक है। यहां देखो, यहाँ पे 4 है, ठीक है, और यहां देखो, यहाँ फिर से 3 है, ठीक है। तो ये वाली जो प्लेट है, ये वाली जो प्लेट है या फेस बोल दो, इस एक प्लेट में 4 × 3 है, 4 × 3 बोल दो या 3 × 4 बोल दो, समझ में आ रहा है? अब आपको सारे कॉम्बिनेशन दिख जाएंगे, राइट। तो 3 × 4, 4 × 3, और वो कितनी बार हो जाएगा? वो हो जाएगा आपका 3, 4, 5, 6, ठीक है, ठीक है, 6 बार हो जाएगा, ठीक है। और इसको आप आगे पीछे भी कर सकते हो, आप ऐसे लिख सकते हो 6 × 4 × 3, ठीक है। तो इससे आपको सारे कॉम्बिनेशन दिख जाएंगे। एक और तरीका भी बचता है, एक और तरीका भी है अगर आप सोचो तो, ठीक है। थोड़ा डायग्राम मैंने उल्टा पुल्टा बना दिया है, ठीक है, बट आपको लॉजिकली समझ में आ रहा होगा कि क्या हो रहा है, ठीक है। अगर आप सोचो तो एक हम ऐसे भी सोच सकते हैं, ठीक है, एक प्लेट हम ऐसे भी सोच सकते हैं, इस तरीके से भी सोच सकते हैं, ऐसे, ठीक है, जो इसके अंदर होगी, ठीक है, ऐसे प्लेट होगी, फिर उसके ऊपर दूसरी और फिर तीसरी, ठीक है। तो ये कितने हो गए? ये हो गए 6, ठीक है, और ये कितने हो गए? 4। तो वहां से भी आ जाएगा 6 × 4 × 3, ठीक है, या फिर 4 × 6 × 3। तो सारे कॉम्बिनेशन आ गए। हाँ, डायग्राम गलत है, डायग्राम थोड़ा बहुत गड़बड़ है, यहाँ पे मैंने 7 बना दिए, ठीक है, ये 6 ही है, ठीक है, यहाँ पे एक कुछ डायग्राम गड़बड़ है, पर आप इसको समझोगे ध्यान से तो आपको समझ में आ जाएगा, ठीक है। अमन, तुम पॉज करके समझना, समझ में आ जाएगा, ऐसे भी बहुत हार्डकोर वो चीज नहीं है, ठीक है। आप आइडिया समझो, ठीक है, कि आप ऐसे ऐसे नाप रहे हो या ऐसे ऐसे नाप रहे हो या ऐसे ऐसे नाप रहे हो, ठीक है। यही समझ में नहीं आ रहा तो भाई तुम्हारा केमिस्ट्री में जब सॉलिड स्टेट पढ़ोगे तब क्या होगा तुम्हारा, ठीक है। थोड़ा सा अपनी विजुअलाइजेशन को बढ़ाओ, ठीक है। मैं ज्यादा समझाऊंगा तो बैंड बच जाएगी, कुछ है नहीं इसमें खास, ठीक है, इसमें कुछ खास नहीं है। जब मैं बोला था कि टफ कराऊंगा तो ये कुछ टफ नहीं है इसमें, ठीक है, ये थोड़ी बोला था ये थोड़ी टफ है, ठीक है, ये तो स्टार्टिंग पॉइंट है, ठीक है। अब मेरा पॉइंट क्या है, आपको इस टाइप की चीजें यूज नहीं करनी है। क्यों? क्योंकि जैसे ही मैं बोलूंगा कि इसको भी मल्टीप्लाई कर दो मान लो 11 से, तो फिर तुम्हारी बैंड बच जाएगी, ठीक है। फिर क्या तुम 4 डायमेंशन में जाओगे, क्या 5 डायमेंशन में जाओगे, ठीक है। तो ठीक है, इसीलिए कह रहा हूं कि दिस इज नॉट गुड, दिस इज नॉट गुड, ठीक है। बेटर ऑप्शन इज दिस ओनली। क्या आप ऐसे सोचो, फॉर एग्जाम्पल जैसे मानो मैंने इसी में बोला, ठीक है, मानो मैंने इसमें बोला कि into 11, ठीक है। तो उसका मतलब क्या हुआ? उसका मतलब क्या हुआ कि ऐसे 11 और हैं, ठीक है। तो आपने इसको निकाल दिया, into 11 कर दिया। मेरा पॉइंट क्या है, मेरा पॉइंट क्या है, एब्स्ट्रैक्टली अगर आप समझोगे तो आप कैसे जाओ, जैसे जाओ वैसे आप उसको वो कर सकते हो, और एक एक का एक्सप्लेनेशन है वहां पे। दिस इज नॉट समथिंग ऑब्वियस, बस उतनी सी बात मैं आपको बताना चाह रहा था, ठीक है। तो ये तो एक सिंपल सी ऑब्जर्वेशन थी जो इंडियंस ने करी थी, ठीक है, और ये आप सब लोगों को पढ़ाई जाती है कि एसोसिएटिविटी प्रॉपर्टी नाम से पढ़ाई जाती है, ठीक है। तो उसको तो छोड़ते हैं, उसको तो छोड़ते हैं। जो नेक्स्ट उन्होंने करी ना, दैट वाज द मोस्ट अल्टीमेट ऑब्जर्वेशन, जिससे लगभग सारा कुछ बनता है, ठीक है, एंड दैट इज वेरी वेरी इंपॉर्टेंट। तो जो नेक्स्ट ऑब्जर्वेशन इंडियंस ने करी, दैट वाज बहुत सिंपल सी, ठीक है। क्या उन्होंने बोला, यार 5 एप्पल्स प्लस 3 एप्पल्स कितने होते हैं? 8 एप्पल्स। 5 ऑरेंजेस, 3 ऑरेंजेस, 8 ऑरेंजेस। 5 बॉक्सेस प्लस 3 बॉक्सेस कितने होंगे? 8 बॉक्सेस। चाहे उन बॉक्सेस के अंदर 50 चीजें पड़ी हुई हो, है ना, उन बॉक्सेस में चाहे 50 चीजें पड़ी हुई हो, सही बोल रहा हूं? तो बस वही पॉइंट है कि 5 बॉक्सेस प्लस 3 बॉक्सेस 8 बॉक्सेस के बराबर होंगे, और बॉक्स के अंदर क्या है, बॉक्स के अंदर कितनी भी चीजें हो, ठीक है। तो वही मैंने यहां लिखा हुआ है कि 5 37 क्या है, वो एक बॉक्स है इसके अंदर 37 चीजें, ऐसे मान लो। तो 5 of 37, 3 of 37 बराबर होगा 5 + 3 of 37, ठीक है। तो इतनी ऑब्वियस रिजल्ट था, ठीक है, जो यहां पर आ गया, यहां पर आ गया, ठीक है। तो एकदम से बात निकल के आ गई, एकदम से बात निकल के आ गई, क्या निकल के आ गई कि यार बिल्कुल बिल्कुल ऑब्वियसली कि 5 × 37 + 3 × 37 जो होगा वो बराबर हो गया 8 इंटू 37 के। ये तो आ गया बिल्कुल आपकी ऑब्जर्वेशन से, ये ऑब्जर्वेशन से आ गया। अब इसको हम इंडियंस ने अपना एक अलग से नाम दे रखा है कि 37 कॉमन ले ले। हम बोलते हैं 37 कॉमन ले ले, ठीक है। तो वो कुछ कॉमन वॉमन नहीं होता है, ठीक है, कुछ कॉमन वॉमन नहीं होता है। जब आप बोलते हो ना कॉमन ले लो, तो वो कॉमन ले लो कुछ नहीं होता है, ये ऑब्जर्वेशन है। और इसको शॉर्टकट में हम ऐसे बोल देते हैं कि एक काम 37 कॉमन ले ले, तो हमने कहा ठीक है ले लिया कॉमन, ठीक है। तो हम ऐसे शो कर देते हैं इसको इस तरीके से, और फिर हम बोल देते हैं देखो 5 + 3 तो 8 होगा एंड सो ऑन, ठीक है। तो ये जो हम ये बीच की नौटंकी करते हैं ये कुछ नहीं है, ठीक है। रियलिटी बस यही है, ठीक है। ये सब हमारे तरीके हैं बस शो करने के सेम चीज को, वही शॉर्ट हैंड है, एब्रीवेशन है, हमारी तरीके की नोटेशन है, ये हम ऐसे इसको शो करते हैं,
शॉर्ट हैंड,
ठीक है। ठीक है, मैं इन सब चीजों को थोड़ा जल्दी निकल रहा हूँ, ठीक है, जिससे कि मैं थोड़ा डेप्थ अभी इसमें आने वाली है, ठीक है। अब इसी चीज को आप थोड़ा दूसरे तरीके से भी सोच सकते थे, ठीक है। इसी चीज को आप थोड़ा दूसरी तरीके से भी सोच सकते थे, जैसे यहाँ पे दे रखा है, ठीक है। ये बहुत ध्यान से समझना, ठीक है, आपको एकदम से समझ में आएगा क्योंकि मैं अभी आगे थोड़ा ज्यादा चॉपिंग करूंगा, ठीक है। तो जैसे इतनी सारी बॉल्स रखी हुई थी, जगह इतने सारे एप्पल्स रखे हुए थे, ऑरेंजेस रखे हुए थे। अरे यार तुम अभी रुक जाओ, ठीक है, अभी 5 मिनट रुको फिर तुम्हें पता चल जाएगा। तो या फिर किसी और से पढ़ लो। तो जैसे यहाँ पर इतनी सारी बॉल्स हैं कि 1 2 3 4, ठीक है, और ये क्या है 1 2 3 4 5 6 7, ठीक है। तो 4 × 7 है, ठीक है। तो हमें तो पता है कि सर ये तो आप 4 × 7 बोल दो या 7 × 4 बोल दो, बात एक ही है, बात एक ही है, ठीक है, ठीक है। लेकिन मैं अगर इसको चॉप कर दूं, मैं बोल दूं यार इतनों को एक तरफ कर दे, इतनों को एक तरफ कर दे, तो मैं इसी रिप्रेजेंटेशन को जहां मैं बोल रहा हूं कि यार ये कितनी बॉल्स हैं, ये 4 × 7 है या ये 7 × 4 है, इसी को मैं दूसरे तरीके से भी बोल सकता हूं। मैं बोल सकता हूं ये तो 4 की 2-2 रोज है ना, ठीक है, ये तो 4 की 2-2 रोज है, तो इनको 4 × 2 बोल सकते हैं। फिर सिमिलरली ये तो 4 की कितनी कितनी रोज है, ठीक है। ये इसी तरीके से समझना, समझ में आएगा वरना नहीं समझ में आएगा, क्योंकि ऐसे ही बना था, ठीक है। तो 4 × 5, ठीक है। तो आप बोल सकते हो ना कि 4 की 5-5 है, 4 रोज हैं 5-5 बॉल्स की, राइट राइट। तो इसी चीज को अगर मैं मिला दूं तो ये टोटल कॉम्बिनेशन बन जाएगा, राइट। तो टोटल तो अभी भी उतना ही है ना, 4 × 7, ठीक है, ठीक है। अब इसी चीज को आप बिल्कुल दूसरे तरीके से भी सोच सकते थे, कैसे, ऐसे कि ये तो सर 2 कॉलम्स हैं जिसमें 4-4 चीजें दे रखी हैं, राइट। तो 2 × 4, सर ये तो सर 5 कॉलम्स हैं जिसमें 4-4 चीजें हैं, तो 5 × 4, राइट। तो अगर आप इनको जोड़ोगे तो आपको समझ में आ रहा होगा कि यहां पर भी वही चीज होती है कि हम बोल देते हैं 4 कॉमन ले ले भाई, 4 कॉमन ले ले, तो ये 2 + 5 बन जाएगा, ठीक है। तो फिर ये आपका बन जाएगा 7 × 4, और ये 4 × 7, यहाँ पे आप 4 कॉमन ले लो, जो आगे से कॉमन ले लो तो बन जाएगा 2 + 5। तो आप आगे से और पीछे से ऐसे कॉमन लेते हो, ठीक है। अब मैं इसको एक लेवल और ऊपर लेकर जा रहा हूँ, ठीक है। आप डायरेक्टली समझ सकते हैं इस चीज को, ठीक है। अगर ये समझ में आएगा तो फिर आपको ये बताना है, ठीक है, दिस विल बी अ बिट दैट बेस। तो आप इधर
आगे से पीछे से ले लो, मतलब क्या आ रहा है बेसिकली यहाँ पे बीच में डंडी खींची तो देयर आर 2 पॉइंट ऑफ व्यूज टू लुक एट इट। ऊपर वाला यहाँ साइड वाला में यू गेट 4 × 2 because and then you get another 4. Wait, what? There's something going on which is not wrong. Just I can get a gist of what is going on, but not entirely. Like 4 × 2, like 4 है और 2 है. Similarly 4 है और 5 है. In the other way, it is like 2 है और 2 into 2 5. It's just the same thing, bro. Come on. इसमें है कि 2 × 5, ठीक है. I want to know what the fuck. 4 कॉमन ले ले, 2 + 5. हाँ कॉमन ले ले वाला एस्पेक्ट यहाँ पे क्यों समझ नहीं आ रहा मुझे. Like what's going on? In this particular question, why am I not able to understand what common ले ले वाला aspect is? Like there is this notion to right. So here, like, if you were to look at the previous example which we talked about, which is 5 × 37 plus 3 × 37 is equal to 8 × 37. Right. Here basically I assumed we have made this thing got easier for me to assume when I assumed 37 to be a box which has some internal shit. Some it could be like X. Like 37 could be like X, right? So that's like a common thing. Now in this particular scenario, what he's trying to say is basically 5 into 37 plus 3 into 37 plus 8 is equal to 8 into 37, right? So 5 plus 3 add ho gaya. And that gave us 8. 37 was taken in common, right? And in this situation, what he's trying to say is 4 into 2 plus, uh, plus 4 into 5 is equal to whatever you are getting. That is basically 4 common liya. Five plus 2. That's 4 into 7. Right. Now here 4 common liya and here 37 common liya are two different things, I suppose. I don't know. Like why appearing to put two separate things, but I don't understand. Like I want this to be free. Like I want this to be fitting into the box analogy that I created, right? The fact that इसमें differentiating factor सिर्फ ये ही है. Like the 4 balls, the 4 rows is common among them. So this could be n number of rows, right? So let's assume, but that implies we know that they both have the same number of rows. Rows नहीं, rows actually, it's rows only. Columns तो ये होता है, rows ये होता है, right? Fair enough. So fuck, I want you to see my note also. But sadly उतना budget नहीं है. So I can put another camera on top of it. I'll just here. I can do one thing. I can actually like share my screen and do it on pen tablet, but I'll do it some other time where I have computational power. What was that word again? Computational? What? Wrong, maybe. I call it Rulliard. Think of it as an entangled limit of everything that is computationally possible. Entangled limit of everything that is computationally possible. So what was this whatever document trying to say? Paper present an extension of observer theory within the context of Roliad using a mathematical rigorous formalization with the category theory as unifying framework. The paper demonstrates how interaction between observers and the Roliad could give rise to hierarchical domains of reality through sampling constraints, information integration, and entropy reduction. Okay, fair enough. Why I didn't understand the last part of it, but it's okay. By formalizing the observer as an active agent, that samples and integrates information across different domains, we provide novel approach to understanding consciousness, causation, and the nature of reality within the computational framework. Didn't understand. The framework reconciles discrete computation structures with apparently continuous observer experiences, addresses the causal relationship between. Okay. Extension to the Wolfram model is what I understood. Like Wolfram is, I don't know what Wolfram is, like some kind of company or something. Okay, I want to read what this paper is for. For philosopher mind, for general readers. Let's see what for philosopher's mind first. We recommend starting the section 1. Wait, let me just start with this one only. If you are coming from a broad interest in physics and consciousness or computation and philosophy without deep technical background, we suggest the following. Read the introduction, skim section 1 and pick up the key definitions in the word. Don't worry if the notations is different. The summaries at the end of each section will help. After that, you might jump to section 4.1, which is a high level and discusses the with this formalism implies of our understanding of our consciousness in the relatively accessible terms. Section 5 is beginning to see the big questions we tackle. The summaries at the end of each section are designed to plain language explanation. Make use of them to build intuition. Finally, conclusion and the section 7 are written in a less formal tone. These sections will solidify your understanding without the math. And remember to consult glossary whenever a term like observer function or entropy reduction appears. They are plain English equivalents with rough correspondence to terms across the different related disciplines. Fair enough. So he want me to first start off with the section 1, skim through the section 1, read the introduction, skim through the section 1, pick up the definitions of course, and then go to the section 4.1, and then go to section 5, and then go to section 7, right? Or maybe you can just read the conclusions of the section. Let's see. Okay, do I read the abstract? Yeah, for sure. The paper visits the extension of observer theory within the context of relied using, I think they actually just said the same thing, right? We conclude the empirical predictions and applications across physics, computer science, and artificial intelligence, formalizing observer as an active agent that samples. Okay, fair enough. So yeah, I think we should just get started. Introduction. The relationship between observer and reality represents one of the most fundamental questions in both physics and philosophy. The relationship between observer and reality represents one of the most fundamental questions from both quantum mechanics measurement problem to problem of consciousness. The role of observer plays fundamental yet lacks a formal explanatory framework, especially given that the observer is a part of the very system it measures. From quantum mechanics measurement point of view, measurement problem to problems of consciousness, which is going to be talked about in sixth section. Okay, fair enough. The role of observer appears fundamental yet lacks a formal explanatory framework, especially given the observer is a part of the very system it measures. Fair enough. Recent developments in computational models of physics, particularly the concept of Rayleigh, developed by Wolfram and formalized by Goddard et al., offer a promising framework for addressing these questions. But what was that question they were talking about? The relationship between fundamental questions represents one of the most fundamental questions. Okay. The relationship itself is a fundamental question. Fair enough. The paper builds upon these foundations to extend ideas of Wolfram, Rickles, including their recent minimal observer model, which can be thought as a potential mechanic for the categorical structures described in this paper. It proposes observers sample regions of the Rayleigh based on computational constraints, creating hierarchical sampling domains that exhibit distinct informational properties. It proposes observers sample regions of the Rayleigh based on computational constraints, creating hierarchical sampling domains that exhibit distinct informational properties determined by the rules that bound each other informational domain. Through this lens, I aim to address long-standing questions about emergence of causality and the nature of consciousness, emergence of causality and the nature of position to the computational universe. The central aim of the work is to establish a formalism that incorporates what we describe as value and meaning into our understanding of reality grounding subjective experience, purpose, and value within the category theory. We seek to bridge the divide between objective description and subjective meaning that has characterized much of modern science. This approach offers a potential unification of two cultures: the scientific pursuit of objective description and the humanistic pursuit of meaning and value. Our approach is distinguished by several key innovations: the category theoretic formalization of observer sampling process, the hierarchical model of कुछ तो बोल रहा है कैटेगरिकल थिंकिंग व्हाट कैटेगरी एक तो कैटेगरी थियरी करके कुछ है भाई देखते हैं लेट्स सी is a branch of matter that studies abstract structures and relationship between them, providing a unifying framework for various mathematical concepts. Whoa. I mean, I just feel left out, but then that's okay. I can't just be fucking dumbed all the time. I mean, whatever. Background, the Rayleigh and category theory. Definition, yeah, this is what I'm talking about, right? He gives us definitions of all these things. That's pretty good. A meta-structural domain that encompasses every possible rule-based system or a computational eventuality that can describe any universe or mathematical structure. It acts as a theoretical space wherein boundaries between map and territory blur, functioning as the ground for the possibility of multi-computation. Within the Rayleigh, every conceivable physical and mathematical system can be situated, but their accessibility or meaningfulness is determined by the specific observer-related frames or constructs. The Rayleigh is thus a free physical framework, and its utilization in physics is to pinpoint exact rule-based system that corresponds to our observed reality. A computational definition is as follows. Let R be the space in all possible computational rules. We refer R as the Rooleard space. We consider R. R may represent either a rule or a collection of rules generating computational universe. Rooleard denoted by R is a collection of all computational universe. That is, I don't know what the fuck this rotation is. Furthermore, observer O can interpret or access the subset of R based on the specific observational constraint. The observability of UR and is contingent to the observer's computational boundedness persistence in the what the fuck is going on? Observer and observer sampled Rooleard. Critically, all observers ultimately sample the Rooleard, but each samples in their own unique way. Observer samples Rooleard in a way that yields are familiar physics. An alien or AI might sample different slices, but a consistent observer still picks out some subsets RO of the Rooleard. Okay. Observer accessible subsets of the Rooleard RO is constrained by what? Boundedness. X must lie within this bounded computation capacity, not too large, not too large. Beta represents some minimal threshold required for observer to sample. Persistence, much. Boundedness, persistence, and relevancy rules. Relevancy rules. X must persist minimum number of hypergraph updates such as 0. Observer field not defined. What the fuck is going on? I'm trying to understand, but no. Section 1 introduces the conceptual backbone of our framework, the Rooleard. As summary, I think I wanted to watch something conclusion. Yeah, I think, yeah, it's a little big on this. I can understand what you're trying to say. Sort of ultimate mathematical cosmos containing every possible universe. When we then formalize what an observer is in this context, essentially a filter or a function that selects by something called foliation a silver selects a silver of that cosmos to call what its reality. We broke down the observer's constraint into boundedness, persistence, and relevance. Limited conceptual computational capacity needs stable patterns and relevance, focusing on what matters. These constraints determine which events in the Rooleard observer can actually experience. Think of observer as both the sculptor and spectator, carving out a personal world from the grand block of marble that is Rooleard. By the end of section 1, we have a toolkit definitions, Rooleard, all possible states and rules. RA, observer's accessible portion. F naught, what the observer actively sees at a given time. Measures in the given measures information and integration to quantify experience. These forms of language we'll use to discuss everything from physics to consciousness of coming sections. Essentially, now we now have a common formal ground to talk about how world of an observer emerges from the world of all the possible worlds. Dang. Section 2 reveals the hierarchical picture. We saw that observer's world RO isn't monolithic. It can be stratified into different domains of information. Each of its degree, structure, verification. Crucially, we learned that domains are nested in whatever.
तो इधर सोचो, फिर से वही 4 है, ठीक है, तो 4 इंटू 2 है, ठीक है, यहाँ पे 4 इंटू 5 है और ये 4 इंटू 1 है और इन सबको आपने जोड़ दिया है, ठीक है। अब देखो मेरे को
commonality I think established इसलिए हुई because you could somehow figure out that there are 4 these things, and because there are 4, so what's variable is different is वो जो डिब्बे में डालने का जो नोशन है, you would put anything that is common उसको in the डिब्बा, like डिब्बे में डाल रहा है ना, तो that's what you're doing essentially, right? डिब्बे में डाल दे रहा है, but how do you like explain this डिब्बे में डाल देना? Like taking common is essentially डिब्बे में डाल देना. Can I say that एक डिब्बे में डाल देना, उठा के एक डिब्बे में डाल देना, वो पता नहीं डिब्बा क्या है. So common can be taken like most easy concept. Never mind. What is it trying to say?
ले ले तो ये 2 + 5 बन जाएगा, ठीक है, तो फिर ये आपका बन जाएगा 7 इंटू 4 और ये 4 इंटू 7, यहाँ पे आप 4 कॉमन ले लो, जो आगे से कॉमन ले लो तो बन जाएगा 2 + 5। तो आप आगे से और पीछे से ऐसे कॉमन लेते हो, ठीक है। अब मैं इसको एक लेवल और ऊपर लेकर जा रहा हूँ, ठीक है, आप डायरेक्टली समझ सकते हैं इस चीज को, ठीक है। अगर ये
Here basically we'll have to take something like 4 common ही लेंगे इसमें भी, but here we'll take 3 times common. 3 डिब्बे
समझ में आएगा तो फिर आपको ये बताना है, ठीक है, दिस विल बी अ बिट दैट बेस। तो अब इधर सोचो, फिर से वही 4 है, ठीक है, तो 4 इंटू 2 है, ठीक है, यहाँ पे 4 इंटू 5 है और ये 4 इंटू 1 है और इन सबको आपने जोड़ दिया है, ठीक है। अब देखो मैंने मेरे को ये गिनने की भी जरूरत नहीं है, कि डायरेक्टली डू दिस, ठीक है, कि मैंने डायरेक्टली इनको जोड़ दिया एंड 4 इंटू 8 आ गया।
दिल में करा के तेरी Okay, so what's the other one basically? It's basically just like opposite of it, like, yeah, whatever. It's just a
ठीक है,
bullshit.
और मैं इधर से भी गिन सकता था, बिल्कुल जैसे अभी हमने किया, ठीक है, तो वो तो आपको समझ में आ गया, ठीक
Fair
है।
enough,
इसको मैं
yeah.
लिखूंगा कैसे अपनी लैंग्वेज में, मैं ऐसे बोलूंगा कि 4 इंटू 8 है ये, ठीक है, पर मैं इसको ऐसे कर रहा हूं कि मैंने 8 को चॉप कर दिया, 3 पार्ट्स में, राइट, कि
8 को चॉप कर दे 3 पार्ट्स में, इज अ वेरी
2
गुड लाइन.
+ 5 + 1,
Oh yeah, pretty much.
ठीक है। और सर मैजिकली ना इसको हम क्या बोलेंगे कि ये ऐसे डिस्ट्रीब्यूट हो जाता है बेटा, ठीक है, ऐसे पढ़ाया जाता होगा तुम्हें, ठीक है, कि ये हो जाएगा 4 इंटू 2।
Oh, this is distributed property. Well, let me just give it a little gist.
फोर इंटू 5 एंड 4 इंटू 1 ऐसे बेटा डिस्ट्रीब्यूट हो जाता है, ठीक है, ऐसे पढ़ाया जाता है। या फिर क्या बोलेंगे, अगर ये दे रखा होगा तो बोलेंगे 4 को कॉमन ले लो, तो कॉमन लेके बेटा ऐसा बन जाएगा, ठीक है। ये दोनों ही चीजें पढ़ाई जाती हैं, ये है उसका लॉजिक, ठीक है। अब एक स्टेप आगे बढ़ते हैं। अब मैंने क्या करा, मैंने अब उसको दोनों तरफ से चॉपिंग कर दी, मैंने दोनों तरफ से चॉपिंग कर दी।
So those are something like it means basically you have to like create like a lot of boxes. Like you have to probably first resolve the upper part and then you resolve the second lower part, or maybe you have to like even resolve it like this also. You know what I mean? Like suppose what it is basically do is basically there's an end limit to what is how many number of possibilities that exist. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 possibilities that could have existed totally, right? That's what happens, and then you can simply go by like section by section to resolve those 10 whatever possibilities, right? What he did basically is that he 2 into 3 पहले ऊपर वाले को रिजॉल्व कर, लाइक यू कैन दैट्स व्हाट आई एम ट्राइंग टू से, ऊपर वाले एंड नीचे वाले को रिजॉल्व कर, लाइक 2 into 3 plus 2 into what is this basically 1 2 3 4 5 2 into 5 plus 2 into 2 into 2 2 into 3 2 into 5 2 into 3, and now you talk about, now you move on to basically 3 into 3 to 3 3 into 5 3 into whatever, right? So that's how you can probably take both of them common and you add to 3 to 5 and then it becomes 5 into stuff. So basically that's how you can probably, I don't know, yeah, pretty much.
ठीक है, तो ये इधर वैसे तो 5 है और ये कितना है, ये 3 और 5 और 5 आई गेस 10 है ये, ठीक है। तो वैसे तो हमें पता है सर 5 into 10 है सर, ये 5 into 10 है।
Yeah, there are a lot of other ways you can do it.
लेकिन इस बार हमने क्या करा, हमने 5 की चॉपिंग कर दी 2 + 3, ठीक है, और 10 की हमने चॉपिंग कर दी 3 +
अबे ऐसे
5
था क्या
+ 2 में, ठीक।
अरे यार, yeah, fair enough. So it's literally, yeah, fair enough. Because what I did was basically 2 into 3 into 5, 2 into 3 plus 2 into 5 plus 2 into 2. Similarly, 3 into 3 plus 3 to 5 this thing or two, and then I was wondering like what to do next. Like I thought probably we could somehow take these things entirely common and then probably add it, and then yeah, actually that's pretty much what I thought. This is what I thought basically. I didn't like visualize it that beautifully, but I was like, yeah, if we can take that common multiplication by part common, we'll remain with like 2 and 3, 2 plus 3, so we can like club them up, and then we just have to multiply with all the bullshit that's remained here on the other side. That's pretty much what I thought, but I couldn't visualize it like that instantly.
ठीक है ठीक है लेकिन मैं कह रहा हूँ कि अगर तुम इसको भूल जाओ तो isn't it
Why do we need affirmation all the time, bro? Come on. That's a tweet from my end from this time. Let me just pause my screen because I don't want to like basically. Can I do that? Can I do? Okay, wait. I'll fucking tweet it in this side. That's it, people. I what I wanted to say. Let's move on.
the same problem? Isn't this the same thing? ठीक है ये अभी भी आप बोल सकते हो ना कि 2 की 3 रोज है सर 2 की 3 रोज है सर 2 के 5 ठीक है सॉरी 2 की 5 नहीं है सॉरी 3 की 2 रोज है ठीक है इसमें फिर 2 रोज है 5 की और यहाँ फिर से 2 रोज है 2 की ठीक है फिर सर आगे बढ़िए अगर आप इधर से पढ़ेंगे तो आप बोलोगे सर 3 रोज है 3 की सर 3 रोज है 5 की एंड सर 3 रोज है 2 की राइट और बिल्कुल आप इसी तरीके से यहां से भी कर सकते थे बिल्कुल इसी तरीके से आप यहां से भी सोच सकते थे
Yeah, the reverse of it. That's pretty
ठीक है समझ रहे हो और यही आपको कराया भी जाता है
If we do this thing here and that thing from the upper side, would that make sense? Like suppose what he's trying to say is like कि 2 की 3 है 2 rows है 3 columns है right? That's what he's trying to say. Is this column or is this row? Whatever. So what if we do is basically we do 3 into 3 into 2 plus 5 into 2 plus 2 into 2. But नीचे will keep 3 into 3 plus 3 into 5 plus 2 and 3 into 2. But yeah, it won't have that, what do you call, like that commonness वाला जो element वो दिखता है जो वो नहीं रहेगा. But it's okay, never mind. It's anyway doesn't was not so good.
कि बेटा अगर आपको इस टाइप का कोई एक्सप्रेशन दिख जाए ना तो आप इसको ऐसे कर लिया करिए 2 into 3 2 into 5 ठीक है and 2 into 2.
So the conclusion, like some marking that I can give it to myself, this is basically distributive property, right? So it's not chopping की बात कर रही है. That's a nice term to remember as to what exactly is happening. distributive property is basically chopping हो रहा है.
ठीक है फिर बोलेंगे अब बेटा आप काम करिए अब इस पे आइए फिर बोलेंगे 3 into 3 3 into 5 3 into 2 ये रहा.
How many sections?
तो ये
how many sections में form like basically in this this thing also 1 2 3. Let's assume I'll create a new one. Right? So this is a new chopping, let's say. There you go. This is a new chopping. So now here, what are we supposed to do? We're supposed to basically take 3 into 2 plus 3 into 3 plus 3 into 1. This is one section which is going to be added somehow to the other section, right? Because we have another section to take care of as well. So 1 into 2 plus 1 into 3 plus 1 into 1. So now if we take both of these commons, it's 3 plus 1 into 2 plus 3 plus 1. So basically that's what happened. This is basically it. The chopping mein you have to create more sections, like how many sections that you can create basically. Right. That's pretty much it.
पहले ऐसे है यहां से ये ऑब्जर्वेशन बनाई इंडियंस ने एंड फिर वहां से इसको शॉर्टकट में ऐसे लिखा. दिस इज अ
Substitution method, yeah.
समझते हो ना? It is that kind of a thing.
It is a substitution, like that kind of a thing. What is it trying to say? Like basically shorthand, basically, yeah. So chopping, distributive property as an essential. This essentially is chopping. This essentially is a shorthand. Back end is this.
जो हमने वहां पढ़ी थी कि इसको सब्स्टिट्यूट कर दिया, हमने इसको शॉर्ट हैंड बना दिया, ठीक है, हाकुटो वही चीज, ठीक है। तो ये आपको ध्यान रखना है, ठीक है। अब अगर आपको ये समझ में आया, तो मैं थोड़ा सा चीजें अभी और ऊपर लेकर जाऊंगा, ठीक है। आप ऐसे भी समझ सकते थे कि सर व्हाई नॉट वी डू फ्रॉम हियर, ठीक है। अगर आप सोचो, जब मैंने बोला 2 into 3, तो व्हाट यू आर लिटरली डूइंग इज यू आर काउंटिंग दिस कि सर 2 के 3 है। जब आप बोले 2 into 5, तो 2 के सर 5 है, दैट इज हाउ यू डूइंग दिस, ठीक है। फिर आपने ये गिना, ठीक है, कि 3 into 3, 3 into 5, 3 into 5 एंड 3 into 2, ठीक है। अब बिल्कुल इसी तरीके से मैं दूसरी तरफ भी जा सकता हूं, राइट। आई गेस ये मुझे समझाने की जरूरत नहीं है।
दूसरी तरफ जा सकते हो आई थिंक। The fuck, my keyboard's about to fall. Whoa, it's fallen. Fallen angels. Fuck. Got it. Now it's not falling. Keyboard, my keyboard is safe. Let's go. So yeah, what I will talk about?
ठीक है, आई गेस मुझे ये समझाने की जरूरत नहीं है कि मैं इधर से भी जा सकता हूं, है ना, कि मैं बोलूं, अगर मैं ऐसे बोल दूं, ठीक है। इसके नोट्स तो आप साथ साथ में बना सकते हो, ठीक है। ये तो बड़ा ही मतलब इसमें तो कुछ आपका वो भी नहीं है, ठीक है।
पानी भी लेके थोड़ा सा।
अगर मैं बोलूं कि 3 into 2, ठीक है, या फिर 3 into 3, तो आपको समझ में आ रहा है कि ये रहा 3, ये रहा 3, तो 3 कॉलम्स 2-2 के, ठीक है, 3 कॉलम्स 2-2 के। इसको आप ऐसे लिखोगे कि 3 into 2। ये बात बहुत अच्छे से ऑब्जर्व कर ली थी। बल्कि अगर मैं तुमसे बोलूं, बल्कि अल्टीमेटली सेम ही चीज आ रही है, कि आप ऐसे ऐसे करो या आप ऐसे ऐसे करो, बात देखिए, ठीक है। तो इंडियंस ने ये बात बहुत अच्छे से ऑब्जर्व कर ली थी। बल्कि अगर मैं तुमसे बोलूं कि इसमें तो कुछ खास ही नहीं है ना भाई, तुम चाहो तो चॉपिंग तुम जैसे चाहो वैसे कर लो भाई। एक बार बताओ मेरे को, एक बार बताओ, जैसे यहाँ पे था 3 + 5 + 2, मैं चाहूं तो मैं इस 3 को भी चॉप कर देता हूं, और क्या है, मैं अगर इस 3 को चॉप करके लिख दूं, लेट अस से 2 + 1, आराम से कर सकते हैं, राइट। मैं यहाँ पे एक और लगा कर लो, तो तुम्हें नहीं लगता सेम ही हो जाएगा वो? तो इट विल बी सेम।
What would happen if we chop every fucking thing, like 1 into 5 is 1 into 2 plus 1 into 2? You know what I mean? Like, oh, just for the sake of doing, I don't know what will happen here, but yeah. Right, so here if we like chop at everything, right, I mean it will be a little weird. 1 into 1. Let's see, this is how I've done it. Like, you can, I don't know if you can see it. This one, I've actually chopped everything. Like, I mean, I've like lined up tuck, 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 like that I've done. So what is going to happen now? 1 into 1 plus 1 into 1 plus 1 into 1. Basically, it's literally like we are actually adding up shit. But tell something, no? Like 1 plus, we are literally like counting each and everything. Now imagine if I don't like put the diagonal one, so it will be like table, I suppose. I don't know. Like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now if I just do like this, then it will be like 1 into 6. 1 into 6, 1 into 6, 1 into 6. इसमें तो पूरा ऐड हो जाएगा, इसमें तो पूरा ऐड। इसमें 1 into 6 plus 1 into 6 plus 1 into 6. So 1 plus 1 plus 1 plus 1 plus 6 plus 6 plus 6 plus 6. Is that what it is? Like, I mean, 6 into 4. So 4 into 6 plus 6 plus 6 plus 6. Come on, like, I don't know if it's really what it is. 6 was it 20? 6 was it? 6 into 4, right? That's what it should be, right? Maybe, yeah, it's just like, sorry, it should just be 1. Plus 1 into 6 plus 1 into 6 plus 1 into, yeah, that's what. So yeah, 4, 6 is 24, so that's what it is. Okay, never mind, why am I doing this?
Right, बस एक कॉलम और एक्स्ट्रा आ जाएगा। अब आप बोलोगे इस बार कि 2 into 3 है ना, 2 into 3, 2 into 5, जैसे आप पहले 3 बोल रहे थे, राइट। मैं चाहूं तो यहाँ पे इसको ऐसे लिख दूं, 5 को लिख दूं मैं 4 plus 1, 2 को लिख दूं 1 plus 1। मैं जितने चाहूं उतने चॉपिंग यहाँ पे भी कर सकता हूँ, यहाँ पे भी कर सकता हूँ,
Yes, sir.
मैं तुम्हारे सामने ये कर दूं कि जैसे मैंने यहाँ पे किया था कि 2 + 3 इंटू 3 + 5 + 2 ये करा मैंने। यहाँ पे मैंने एक और नंबर से इसको मल्टीप्लाई कर दिया, समझ रहे हो? मैंने एक और नंबर से इसको मल्टीप्लाई कर दिया।
Fuck.
ठीक है, जैसे मैंने यहाँ पे मैंने कर दिया 7 + 8। ठीक है, चलो ये कर दिया।
इसमें क्या होगा? That's a good question. Fuck. It's like associative property and distributive property both the same type, right? This is what? This is distributive property. Like in the no, that's not I mean, this is associative, but not like actually associative. Yeah, this is associative property. But wait, chopping. What the fuck am I doing, bro? Come on. So this could be like, I mean, essentially what I do is basically to multiply both of these things and then wait for the answer to come, and then answer says to multiply karega. But what actually is going to happen is something else. Little, I don't know. I have to think. I think I should think in the next live stream. So people, I'm going to come back. I have to poo a little bit and then I will come back.